Hello, thank you for joining me. Now, the question here says a block of mass 1.2 kilogram rests on a level floor. The frictional force between the block and the floor is 1.2 Newton. A horizontal force of 2.6 Newton is used to pull the block for 4 seconds. What is the velocity of the block after this time? Now, I'm going to use two methods to solve this question. So, I would like you to watch to the very end so that you can see how the two methods are applied. Now, first of all, I would like us to look at a sketch. Now, we have something like this. A small block, we say 1.2 kg, is resting on a floor. And then we are told that there's a frictional force that is acting on it. So frictional force opposes motion. Don't forget, friction opposes motion. So the frictional force is 1.2 Newton, opposing the motion. And this is the direction with which the block is pulled by a force of 2.6 Newton. Hope you are seeing the sketch. So the mass of the block is 1.2 kilogram. The frictional force opposing the motion of the block is 1.2 Newton. And the force with which the block is pulled in this direction is 2.6 Newton. So this is a sketch of what the question is actually saying. Now, you agree with me that we can get the resultant force with which this block is moving in this direction, because this force is 2.6 Newton pulling it, but there's a frictional force that is opposing it in the opposite direction, which is 1.2 Newton. So the net force, I can call it F net now. The net force acting on the body or on the block is actually the difference between these two forces, because they are parallel forces and they are in opposite direction. So I'm going to say 2.6 minus 1.2, and that will give me the net force as 1.4 Newton. So the net force with which this block is moving in this direction is 1.4 Newton. Now, let's come back to the law that Isaac Newton gave us. That is Newton's second law of motion. And that law says that F is equal to ma. From that law, we have this formula, F is equal to ma. Now, the net force that is acting on it is 1.4. And the mass of the block is 1.2 kilogram. So mass is 1.2 multiplied by the acceleration, which is a, with which the block will move. So we need to calculate this acceleration first before we have to calculate the velocity of the block. That's the final velocity of the block. So now you agree with me that to get the value of a, I simply divide both sides by 1.2 and this by 1.2. So that 1.2 we cancel 1.2, and that will give me the acceleration of the block as a. Let me write the a first. A is equal to 1.167 meter per second square. So this is the acceleration with which the block is going to move. And then now, let's come back to the question, because we need to get something before we can get the final velocity using the equation of motion. Don't forget, like I told you, there are two methods I'm going to apply in this problem. So watch to the very end so that you get the two methods. Now, we are told that the block was originally at rest. That tells us that the initial velocity is 0. And then don't forget that the time is 4 seconds. So let's go back now and get this parameter so that we can apply the equation of motion to get the final velocity. So I can simply say the initial velocity is equal to 0 because the block was originally at rest. Don't forget, when the body is at rest, its initial velocity is 0. Then the acceleration, we already know that as 1.167. That is the acceleration, meter per second square. The time, as I've told you, as we saw in the question, is 4 seconds. And then we are asked to find the velocity after the 4 seconds. That is what the question finally asks us to calculate. So it says, what is the velocity of the block after this time? So after that 4 seconds, what's the velocity? So that is what we are looking for, and we are exactly applying the equation of motion to do that. So the right equation of motion to apply that contains u, a, t, and v is v is equal to u plus at. So that will be equal to, the value of u is 0 plus a is 1.167 and t is 4 seconds. So finally, if I multiply this 1.167 by 4, it's going to give me 4.67 meter per second. And that is the velocity of the block after the 4 seconds. So this is the final answer. But like I told you before, I have another method that we can apply, and I think that method is shorter. So let's look at it, that from momentum, which actually we got from Newton's second law of motion, that impulse Ft is equal to momentum mv, because we use mv direct because the body started from rest, so there's no need of using u because u is 0. So impulse is equal to momentum. So let me use or here so that we can know that this is another method of solving it. So I'm writing or. Ft is equal to mv. Now, the force, don't forget the net force that we obtain in the question is 1.4. See it here. So the net force is what we are using, 1.4. And then the time is 4 seconds. Don't forget that. So the net force is 1.4 multiplied by the time, which is 4 seconds. And that will be equal to the mass of the block is 1.2. Don't forget, multiply by V. So from there, we can simply say 1.4 multiplied by 4 will actually give me 5.6. So 5.6 is equal to 1.2 V. So to get the value of V, I simply divide both sides by 1.2 and then divide this by 1.2. So this, we cancel this. So I'm left with V on this side. So let me write it first. V is equal to, then 5.6 divided by 1.2 will give me 4.67 meter per second as the final velocity. And you can compare the two. You can see that their values are exactly the same, which shows that we are very correct. So any of the two methods will work for this particular question. Hope you enjoyed this video. Please don't forget to like and share this video so that others can learn from it. And don't forget to join me in my next video. Thank you for watching.